Hello everyone, welcome to Projects with Gaurang, and today we are going to start the fourth lecture of our machine learning series, which is types of machine learning models. So the types of machine learning models, why we are studying? Because different problem statements require different types of machine learning models. There are many types, we will discuss them in this video. So first, before moving on that, we will look at what is the general machine learning pipeline. So in this, there are three steps. First step, you define a very clear problem statement. It should be crystal clear what you want your algorithm to do. For example, let's suppose a very famous example is house price prediction. House price prediction. So in this problem statement, it is clear that we want to build a model which accurately predicts the house price in a given area. That will depend on data also, but that's the crux of the problem. That this is what we want. Then you have to find or create a very good data set for the problem. For example, if you are creating one, in let's just say I'm using this house price example. So what you will look at? Okay, so what is the size of house? Then if there is some special thing like about the house that it is where it is present. Location is a very important factor, that it is near hospitals, schools, different markets. So that is also important factor. Then what are the other amenities in the house? For example, okay, that house also has a front yard and a backyard. So it has a parking space or not. This is also a thing. So there can be different factors. You have to think about it. There are many datasets which people have created. So you can either find one or create one. To find one, that is very easy. You can just internet or Google it, you will find it. Then you have to pick an appropriate model based on these two. That what type of data you have and what is your problem statement, and then choose the appropriate model and solve the problem statement. This is the general machine learning pipe. Now, classification of machine learning models. On what basis a machine learning model is put into a category, and like what are the points where we classify the models. So there are actually five key components that play a critical role in machine learning pipeline and to build a classification of machine learning algorithms. So those components, those critical role, you can say in ML pipeline, becomes the basis of classification. First, what is the type of input data? It is very important because garbage in, sorry, garbage in, garbage out. If your input data is garbage, you can't expect a top of the line output. You have to give a very good input to get a very good output. Now, this is the first thing based on input data. Then, based on the problem statement, what actually the problem statement is demanding you, like what you should do. Then there are certain algorithms, so which machine learning models use inside them. So based on them, there is also a classification. Then what type of solution you want. See, if there is a problem statement, that the type of problem, there is also a type of solution associated with the given problem. So based on the solution, and then based on the output data, that what type of output data you expect or you are giving in training of machine learning model, or maybe you are not giving the output data, we will look into it. Don't worry. So, nature of input data. If we are classifying our machine learning model based on input data, there are actually four categories. First is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Kind of this classification is most used because mostly in general conversation we mention the model whether it is of supervised learning, unsupervised learning, and we mostly use this supervised learning in practice, but in reality, semi-supervised is most used. I will show you why and how. Then we will move on to supervised learning. What is supervised learning? Supervised learning is nothing but where you have labeled data. See, there are shapes and there are labels. So you exactly know, okay, this shape is a rectangle, this is a circle, this is an ellipse. So this is the thing. And then you give this labels, that is called inputs. and outputs to this machine learning model, and this machine learning model trains on it. For example, let's suppose you gave 90% of the data as trained data, and rest 10% you just reserved so that okay, I have to test the model also. Now, when you trained your machine learning model, after that you started testing it, and you have the predictions. Now, what happens in supervised learning is that you have labels for this test data. You exactly know that, okay, I'm giving you a triangle, I'm giving you a circle. What else I'm giving you, that can also be there. But see, if the predictions are wrong here, for example, I'm giving a triangle and a circle. Here it is predicting correctly. For example, let's suppose in the case of circle, it is predicting, let's suppose, hexagon. Now that's a wrong thing. That's an error. And because we knew the correct answer and the model predicted a wrong answer, we can retrain the model. So there is the benefit of feedback. What is feedback? It is nothing but it's just, you can say, result. For example, when you study and when you give exams, you get score. So if you scored 100%, that's a very good score. Like, you performed correctly. But if you get 90%, 80%, you made some errors and you need to correct them in next exam or in future. So that's the thing. There are certain algorithms which are used. So random forest, support vector machine, linear regression, logistic regression, and so on. In supervised learning, there are many algorithms actually. I just listed four most famous of them. You can also look into it. I will suggest to you look into sklearn library. They have a very long list of different supervised learning models. You will find it interesting. Now, unsupervised learning. What happens in the unsupervised learning is that we don't have that output. We don't have the facility of outputs now. We only have inputs. Sorry. So what happens is that in this, the unlabeled data is fed to machine, and the result is not now that, okay, the machine identifies that this shape is a rectangle. No, this is not the expected output. The expected output is that if I give two rectangles, two circles, and one diamond, let's suppose two diamonds and one hexagon. So it should put each one of them in a separate group. It should not be like, okay, it is saying that this shape and this shape, this is a hexagon, are similar. That should not be the case. This shape and this shape, circle and rectangle, this should not be the case. So this is the thing. This is what we expect in unsupervised learning. So kind of we are making the clusters. That's why these are also called clustering algorithms. So there are many algorithms like k-means clustering, hierarchical clustering, and density-based clustering, dbScan, and many more. So this is also very used in practical applications. Now let's move on to next. Now, semi-supervised learning. This is actually the case which you will encounter mostly with real world data. When you work with real world data, this is the case which you will encounter most. Because what happens is that, let's suppose that I'm taking the same example, this shapes example. What happens, let's suppose I labeled these as rectangles. I'm writing only R for rectangles, this as circle. But for this shape, I never gave you any labels. I don't know what this shape is. Kind of I know, but just for the sake of example. So I didn't tell you what shape is this. I told you, okay, this is the data. Now give me a machine learning model, train it, do whatever you think you can do. So in semi-supervised learning, what we have is, we have a small amount of labeled data and then a really, really large amount of unlabeled data. Then what we do, we combine both of them in a machine learning model and we produce a pseudo-labeled dataset. For example, let's suppose I have 5 categories: rectangle, circle, hexagon, square, and one more category, we can say, what should we take? Let's suppose a triangle. Yeah. Now I have labels for rectangle. I have labels for triangle. I have labels for hexagon, for square, but I have no labels for circle. So I know that 4 out of 5 are labeled. 4 out of 5 we have labels for them. For this fifth, we don't have any label. So we can tell the machine learning model that if you don't find any of these 4 labels, you conclude that the shape is not rectangle or any of these 3, then mark that as a circle. What it will help you is it will give you a pseudo labeled data set. It's kind of not falsely labeled. It will be like you haven't labeled it, the machine has labeled it. And now what you can do is you can train another machine learning model which will be trained on this labeled data and this pseudo labeled data. Now, why I said that it is one of the most commonly experienced or commonly seen in real world data. So what happens is that labeling cost or cost of labeling the data is very high. It is actually very high and it takes a lot of time. So what is generally done in many organizations is that they create a very good and very accurate small data set which is actually labeled. This will be very accurate actually. And then they have a millions of like records or you can say in terabytes of data for this like which is unlabeled, and they will use this machine learning model to label this data so that this can be used in further models here. So that's its application, that it is used to label unlabeled data. That's what semi-supervised learning do. Now there are many algorithms used in this: semi-training, co-training, multi-view training, and the transducive SVM, and so on. There are many algorithms in this space also. It is also application dependent, like if you are dealing with images, if you are dealing with audio, text, even records. So there are different algorithms that work better on any given data. Now, what is reinforcement learning? This is very different from all these three. See, in supervised, what we were doing, we were predicting based on the given labels. In unsupervised, we were clustering. In semi-supervised, we were using the model to label the unlabeled data. So kind of, you can say we are clustering the unlabeled data or we are labeling the unlabeled data. Now, in reinforcement learning, we don't label anything or we don't work with labels. It's kind of giving the machine some intelligence like human. So what happens in reinforcement learning is that there is a reward and penalty system. Now, how it works, I will explain it. Reward and penalty. So, let's suppose you are building a reinforcement model for balancing a pen. Now, if you can see me, if I'm balancing the pen, it fell. Now, the machine will also fail. So, through this, it will record, okay, first time I try to balance, I failed. Second time I failed, but how much time I was able to put the pen in like that position? Let's suppose for first, let's suppose 0.1 second. For second, I also failed, but let's suppose it was 0.25 seconds. So see, it is improving. The time is increasing as we go on. Third entry, something like that. So it builds a table. That, okay, what is the result? Let's suppose you built a model saying that, okay, the pen should stay upright for at least 10 minutes. After that, okay, it can fall. We don't care, but for 10 minutes at least it should be stable. It should not fall. So what will happen? The machine will try to increase this 0.1 second to 10 minutes. But it will not happen in one go. No. What will happen is that it will train itself, it will fail, then during this training we will give some reward. Okay, for 0.1 second, let's suppose any reward. It maintains actually a score variable. So let's suppose score was 0. It maintained for 0.1 second. Let's suppose score we increased by 0.001. Now next time it was like 0.25. So we increased the score to this. So these algorithms try to achieve a maximum value of score. They want to maximize the score so that, or you can say most reward. Let's suppose it failed. Let's suppose with this, now 0.25, it then fell to 0.1 second. Let me clear some space. 0.1 second. So now what will happen? It actually decreased its performance. So I will punish, or I will kind of draw a penalty on the system. So I will say, okay, your total score was 0.001 plus 0.00, sorry, not 00, 0.025. Now I will subtract, let's suppose 0.01. So what I did actually was 0.001. Wait a minute, let me clear it. You might not be able to see brown. So this. So now the score actually decreased. So it will learn from that I made an action, whether I received a reward or a penalty. So based on that, it will decide a course of actions which should be taken to complete the objective. That's the thing. In this, there are two components. There is environment and there is agent. Environment is nothing but just the place where the model or the machine you are building or the agent will operate. Environment where agent operates. Let's suppose one most famous example is self-driving cars. So what happens? In self-driving cars, everything, roads and any infrastructure you see is the environment, the real world. And the agent is that car. So this is the thing. Now there are many virtual environments also. Why? Because there are many things you can't test, or they are very risky to test in a real environment. For example, let's suppose that we have this self-driving car. This self-driving car would have failed numerous times before it actually made it to the reality, or you can say there was a real physical world test, because there are many physical world tests also. So what they would have done, they would not be like, okay, we have built a model, now let's build a car and throw it in the real world. No, that's not how it works, because it might have been that model when it's untrained, it's not sure about any action. So it will make a very random action. Let's suppose someone rammed the car in, sorry, the agent rammed the car in a pole. So that will cost much. So they build virtual environments. Now what these virtual environments give you is that they give you an environment which is very close to the real world, and you can highly customize them. They are highly customizable environments. You train your model or agent, and when your agent is trained enough, then you place them in the real world to further test their performance or anything. And even you can see for unforeseen conditions which you might not have thought when you were building your environment. So there are actually two things you have to build: environment and the agent. So as this video is quite large, so I have divided this into two parts. This is the part 1. Part 2 will be coming soon. So stay tuned for that, and I will see you next time. Bye.